So in the classroom, and various companies provide demo versions of their software. Solidworks has teamed up with CamWorks to provide Solidworks CAM. So that is an add-in in your 2018 education version. And so I just want to take one of the parts, and let's see, I think we had the base, and open any references. All right, so at this point I want to hide the annotations. All right, so each of the demo versions or various versions are going to have some type of limitation. Once you have the license, or you're going through a it's a vendor or yearly maintenance, something like that, it will pick up the geometry, or pick up more of the features to find geometry. So with the add-ins, then we have, let's see, is CAM going to show up here or not? All right, so on the class computers, the class formerly known as GTC 276 was our solids programming. And so that's still available as either special projects or within one of the other CAM. But that gives us the opportunity to look at SolidWorks CAM in 2018. We also have Autodesk HSM, SolidCAM 2018. And then at one point I had the MasterCam demo version. In this case, MasterCam Direct is the handoff into the MasterCam standalone. Right. So there's a couple options for the production of the G&M code to actually make the part. And I kind of want to just highlight a few of the features, so that you get kind of a sense of, once we've created these drawings, how, whether it's a manual operation or CNC operations, how the CAM programs go about generating code to pick up those features. So SolidWorks CAM and CamWorks is, I think CamWorks has been around since about 1999, 2000. My first experience was when ProCam was kind of phased out in 2003 or 2004, and picked up CamWorks. And CamWorks has a lot of features, and one of its strongest is that there is a database of machine operations. So once you start to train this software, how you like to work, how you like to machine, it recognizes a lot of those features, and will provide you with quite a bit of information before you even really get into the designation. So one of the things that is both the help, and it is a little daunting to start getting into, is once you open up the technology database, then the machine definitions, the strategies, various tool cribs that we can work from. At the start, we don't have to do any of this, but at some point you're going to want to get familiar with those various operations, so that you can edit, detail, take it to another level. All right, so this one's still showing up as the metrics, so that would be nice to change over before. Let's see, it didn't find any features, and we haven't set anything yet. So I'm going to switch it back over to inch, pounds, and seconds, and then should be able to send the mill back to inch. All right, so on the NC Manager, there are ways to manage the configurations. So if there was several parts that had similar geometry but was just a little bit bigger, a little bit smaller, maybe not all of the holes, then we could do the configurations, and then also the configurations for the various machines. So one of the things that that comes up is that in the shops I've worked in, we may have a So the example is a VFO with a 10,000 RPM spindle, and then a VF3 with a 7,500 RPM spindle, and then a lower capable knee mill, Analam, the Miltronics are good examples, that is a 4,000 RPM spindle. So if I was to program this as the highest RPM spindle, then the machine will adjust the inches per minute and the RPMs down as it switches or as we add new configurations and tell it what the capabilities of the machine are. So at that one, I program to the greatest capabilities and then have it pull back if it needs to run on more than one machine or all of the machines. The machine definition then, I thought we just changed that, but maybe not. So it was still showing up, metric. All right, we'll see if that picks up. On the stock manager then, we're telling it how big, and it's picking up the aluminum alloys. There are several different, so the bounding box with no offsets, or we can offset the material. I prefer to create a solid body, or my actual preference, if this was a next level up, would be to pull this into an assembly. So in the assembly version, if I was running multiple work offsets, multiple vices, I would have that capability to jump from coordinate system to coordinate system. And on my CamWorks license, I will actually pull this part in, and that does, was, as just said, was being able to populate multiple vices, but then at the other side of it is I'm not making any changes. So if there's any kind of document trail that says I can't modify this part, so whether we've set up an ISO standard or an ISO 9000 document control, as the manufacturing, I shouldn't be modifying this, then I don't want to program over top of this part. I want to bring it into an assembly. And there's other ways that I could do that, but it would involve opening up a new part, inserting it, and then pretty much having that as the separate document. The assembly is a whole lot easier. Anyway, I digress. Coming over to the bounding box, then we can also draw a sketch, bring in an STL file of a representative of the size for castings or previously machined pieces, or actually find a part file that is representative of the stock. Once we apply the stock, then it needs a coordinate system. And so I don't really have an entity. So if I was to go to the x-axis along the face and then the y-axis, I still haven't really given it anything there to work with. So let's just X out of that. So one of my favorites, regardless of the system, is if we look at this from the bottom, Control 6, I'm okay with machining. A lot of times I'll put a target in place. That gives me a good visual reference based on the size, 1/2 inch. And then I need an X and a Y. All right, and then the center of that target is at the intersection of the two. So even though there's a radius there, I now have something that will represent my geometry. And since I'm going to keep hitting Control 7, I'll put a machine orientation in place. All right, so we can get back to the edit definition. If I needed to, I could set up a coordinate system and use the Solidworks coordinate system. I think the target is about as functional. So when I pick an edge, pick the line, that gives me a direction, and I'm just verifying that Z is in the right location. All right, so I can come back and hide that sketch. I don't want to lose it. And then I have two choices. I can go back to the stock manager and say make a mill part setup, or what most of the tutorials and the sales demos will say is extract machinable features. Go find everything. So we got a hole group. So that one looks pretty good. We've got a drill group, And so if I wanted to say that that is not exactly it, then let's see, there is, yeah, it is under the parameters. All right, so strategy is going to be for the ream. So drill in ream. So when it sees the drill, well, that one's a little bit large. All right, with the almost 1 inch. The counter bore, if we look at that one, all right, so drill and mill. And then since that's what it found, the additional geometry, my first operations, would be to insert a 2.5 axis feature and tell it that I'm going to run a facing operation. And it's the outer loop. See if finds the perimeter, or if it found the contour select. Yeah, it should be all right. Okay, and then the in condition. So one of the strange things about the in condition is up to stock. Well, it defaults to up to face or up to stock, but that's not really what I want, and it's not the direction that I want. So if I just go 10 thousandths, that gives it enough material to remove. And so I would call this one of the quirks. Either I've done it wrong for 20 years or almost 20 years, or that's just the way that it picks up the information. There's no islands to remove out of the middle, and I thought that was going to put it first, but apparently not. And then we'll go to 2.5 axis mill. If I do a contour mill, and let's see, from the tool crib. All right, so this is things that are available in the default. So 6.3 would be a 5/8. And let's see, the operation picked up the tech DB. And we picked a tool. And then the features that we want is going to be, somewhere in there should be a depth. So that one picked up must have picked up the face feature again. Let's see if it'll go back to the, now let's just go 2.5 axis feature. So we'll turn off the face feature. This becomes a boss. So there's a lot of definitions in here. If we go to the contour select, no. Okay, so that's the base. It's the outer loop. In condition then is we have a finish, and then we go up to stock or up to vertex. All right, so that has the depth. All right, so what I haven't told it is we're 0.59. If this is a piece of 3/4 inch material, then I have material that I can run all the way around, machine it, and then flip it over and machine off the backside. All right, so sacrificial material to make those cuts. And I don't want to get into too much detail because I don't have plans to really make one of these. We just want to get enough operations that we can go through the process. All right, so when I generate the operation plan, it goes out to the tech DB. It says pick up about a 2-inch face mill, the center drill. All of the explanation points are saying those were not items that were not in the tool crib, so it added them, and it added them whatever was next in the sequence. So it really didn't need to go to a 3/4, and it didn't need to go to a 1/2 inch center drill. And I could probably change those all over to the 1/2 inch, but maybe I don't want a center drill at all, so I'll just get rid of those. All right, so one of the things that I do is go through each of these operation by operation. You can generate the toolpaths from those operations, but I use this as an accounting technique that when I edit the definition and I've gone through the process, so like when we're looking at the MFG 236 master cam, we touch every tab, every operation, just about all the way through every time. All right, so I'm checking the face mill. Don't have so much on the holder. Since we picked up the default tool crib, we would probably establish our own tool crib, and then it gives me more information on the tool. Feeds and speeds are linked to the library. The library needs to be adjusted, so operation-wise, 1675, maybe, let's see what 1,000 looks like. All right, so I was thinking about 2,000 max for a 2-inch insert cutter. Don't know how many inserts that I told I was had. It would be either 3 or 4. And then feed per tooth at 20 thousandths per inch or half a millimeter. That's still pretty aggressive. So maybe we would drop that down to 3 thousandths and get it from 161 down to about 30. All right. So the 2 decimal places afterwards drive me crazy. I'm not going to round those off this time, but most of the time I would pull those 2 whole numbers so that I don't see those decimals all over the place in the program. The facing operation, how do we want it to run? Back and forth, up and down, cut amounts, allowances, just all kinds of parameters. And then what are the rapid planes? 1 inch, 100 thousandths for the clearance plane, and then variations between the geometry. All right, and then the face feature itself, lead-ins, how much it's going to overlap, overrun. And since I didn't tell it how much the stock was, then when I touch off the stock, I'm cutting this oversize, and then I'm responsible at the control telling it to come in a little bit, go over a little bit so that it makes the cuts. All right, so I want to preview the operation. It shows me the toolpaths, and that would be what I would expect to get, and then we can hit OK. The contour then, and the outside, did it not do the boss? I did not pick up the boss, so something in there it didn't like. And then it picked up a 0. All right, let's see if it'll pick that one up then. Okay, so I want to reorder and then edit the definition, so 12 millimeter. All right, so basically the same thing with the cam. We'd go through each, check all of the parameters, and percentages. You have to be careful of looking at percentages, thinking 52 millimeters, no way. But as a percentage, it's going to go a little over 6 millimeters, about a quarter of an inch. And then when we preview it, it's leading in the middle. Not a good place, but we would be able to shift that over to one of the ends on the lead-in. All right, so for a group of these then, let's just say that I've gone through them, and if we generate the toolpath, it's going to go find that geometry, and then find the next group of geometry. And at some point, I'm going to be able to simulate the toolpath. And let's see, how fast are we running? Pretty fast. All right, so we'll go again, rewind. All right, so the facing operation. And then, we have a step and repeat, so that would mean that I also need a finish pass. Since it's taking multiple steps down, if I don't, I'm going to leave that parting line. All right, so in effect, that first operation is establishing flatness. And then as we go around the outside, not that we really required perpendicularity on this one, it's the rigidity of the tool, the accuracy of the setup that is producing our perpendicularity going around the pieces. And then the drill and ream, that's what's going to provide our positional, and that's within the capabilities of the machine to make from part to part or even on the one piece. And then the counter bores opening up for the socketed cap screws. And not sure which one that is. That looks like a deburr operation. All right, so it's taking the 90-degree tool and it's cleaning up the edges. All right, not sure I want to watch all of those. Yeah, sure did. It picked up a countersink, an 1/8 inch countersink, no less, to clean those up. All right, at the end of the game, then we come over to post the operations, depending on post process, and then I have to tell it where I want to put it, and it's saving out as a text file. I did not pay attention to the post file, so whatever generates, we will generate. All right, so it flashes by the code. It gives me a list of tools. And I can certainly go back through and optimize and generate a lot cleaner. So code looks relatively usable. I don't see anything jumping out at me that is too crazy. So let's see which one that did. All right, so just the standard 3-axis tutorial. So one of the things that happens is that we would purchase or we would find a post processor that most closely resembles how we want to machine, and then make small modifications from there to build it out. So the post that I've been using for 19 or 20 years has was developed through trial and error, got it to a point that we're happy with it, and then pretty much staying with it, even though there's a few minor. Each of the programs is going to have their own way of manipulating that post so that it converts these line geometries into that usable code.